Lab 4 going? I hear some giggling. I hear some thumbs up. That's a mixed message, I'd say. There's one typo that I know of in the lab write-up, and that says keep ADC input lines as far as possible from the SPI control lines. That's true. Perhaps use A0 and A1. A0, this was a cut and paste error. A0 controls the LED on the large board. And so if you put voltages into A0, they will be clipped and made nonlinear by the LED dynamics. Don't use A0. It'll clip it around 0.7 volts or so when the LED turns on. But you probably would have discovered that anyway. Some people were having noisy outputs from the potentiometer or the sensor circuit, or from the setting potentiometer. So, and what I suggested last week is to put a 0.1 microfarad capacitor directly from this point to ground as close to the input of the ADC as possible. That seems to help. The other thing which I've noticed is that people are running quick and dirty, and so they're not bothering to low pass filter the motor control signal, and so the output on the oscilloscope for the motor control signal is so noisy it's unusable. And you really do need to digitally filter that to get rid of some of the high frequency noise from the derivative term, which is very fast changing and dominates the display. One group, for reasons I haven't quite figured out, got their motor so hot that it melted off the end of the stick. The hot glue melted. Has anybody else had that problem? I don't know. I don't know. There was one symptom that may be part of that, and that is that when you turned on the motor this morning, it didn't work at all, right? Which implies that maybe there was an internal connection that was a little bit high resistance and was dissipating lots of power, but I don't know. So I didn't have that problem. I ran mine pretty hard for pretty long, and it barely got warm. So I didn't expect anybody to actually melt the hot glue. Any questions about Lab 4? It's all good. Yeah, you're gonna finish. Let me remind you that during the demo, you're going to turn this thing on. It's going to go through a series of 4 different angles. Minus 90, it should start hanging straight down. Minus 90 goes up to 0 at 0 seconds. You command it to 0 at 5. You command it to plus 30 at 10 to minus 30. And then at 15 it back to 0 angle. After that, the system should just sit there waiting for the TA to mess it up. So then the TA is going to go in and modify a couple of parameters to make sure that the user interface works, and probably destabilize the system, but that's fine. The evaluation is going to be the evaluation for settling time and angle and accuracy is going to be to look at the minus 90 to 0 settling time and the 0 to plus 30 settling time and overshoot. So the TAs will be measuring the time it takes to get to 0 degrees within 90% of 0 degrees, the time it takes to get to within 90% of plus 30, and the percentage overshoot of this first peak. That'll probably be what's measured. Any questions? There were a lot of questions in lab yesterday, my spies tell me. I mean the TAs. About what's a PWM? Oh dear. Do we need to go back and talk about PWM? Pulse width modulation? Anybody want to hear PWM again? It could well be a self-selected sample of people who don't come to lecture who needed to hear that. I'm not sure. So let me talk a little bit more about final project then. In particular, if there's no more questions about lab 4, don't want to see anything again, you're all good, then let's talk a little bit about ordering parts. Yeah?
When you're tuning the PID, like if you're getting rid of all the other terms except for the proportional one, are you looking for it to reach, like oscillate between your target, your desired angle? Because what we had was that it wouldn't go, it doesn't have enough power to get up to the actual desired angle.
So if you have only a proportional term, then the drive on the motor, the PWM drive, is proportional to Kp times the error, right? All the other terms are 0. That means if you want to have the error, you have to double Kp, more or less, to get the same drive on the motor. So more or less, the bigger Kp is, the smaller the error will be. Now, the reason you can't take this to infinity and beyond is that at some point, the phase shift will be large enough at high frequency that the system will oscillate. So what you will see is, as you increase Kp, is you will decrease the error again, and at some point the system will start oscillating probably without bound. In other words, it'll hit the stops. It'll go full power to 0 power. Probably where you want to set Kp initially is just to the point where the system is becoming unstable. Just to the point where you put your hand on it, you rise the beam up slowly and take your hand off. It sits there and quivers or maybe starts to oscillate slightly around its equilibrium. At that point, then, you would stop increasing Kp and start increasing Kd. Because Kd is going to add a phase shift to stabilize the system at high frequency. And the oscillations are happening at approximately the resonant frequency of the system, which is something like the free pendulum frequency of the beam. So the answer is not clear exactly what kind of oscillations you want to have around there, except that you probably don't want to have the system going full stop to full stop. Full power to 0 and full power to 0. Does that answer it? Or did I answer the wrong question?
I think I was saying that like even when we're at like max error, it doesn't have, our PWM on time is not getting to, it doesn't get into the desired angle basically. It's not oscillating across.
Are you saying that if you are putting out a full 6-volt signal, it doesn't get to equilibrium? It doesn't get to 0? Your beam's too heavy.
Well, if you just have a proportional gain,
It's just P.
if you just have a proportional gain, like the steady state error is like it's never gonna be 0.
Well, it'll never be 0, but what will happen is that it'll start to overshoot. It'll start to oscillate because of phase shifts at high frequency.
But it won't ever get to your desired angle.
The equilibrium angle will not ever be the correct angle, right?
Then that's what they're saying is happening, right?
But are you saying no matter how much you turn up Kp, it never oscillates?
No, it does oscillate, but it's not at. If you make it like steady state, it's not oscillating across our desired angle.
It's not going ever above it?
No, it's below it.
It's because their steady state error is just never going to be around that, and the overshoot will never go over it.
I mean, if you start from like 0 or rather vertical, it's going to overshoot.
So if you can't, are you telling me you can't turn up Kp enough to make this stuff overshoot the horizontal?
I think it's because they're starting too far away, probably. Like the step input is like.
So if you hold this thing, again, hold the thing horizontally, boot the system up, let go of it. You should be able to find a Kp that's big enough that the oscillations start to grow more or less symmetrically around the equilibrium point, but actually biased a little bit below the equilibrium point.
I'm just talking about this bias and it's towards below the.
Well, it has to be. So add in a little bit of an integral term, which will slowly average out that error. Yes?
All I had was when it's reaching the desired angle, it's just turned off. Or it just like shoots down and then it just goes up, tries to control it, and then when it crosses that, just.
So are you using a large integral term? You're saying it cuts off when it crosses the criterion. Are you using a large integral term?
I used the 2 to the 4th, 1 to the 4th.
So if, let's say your Kp is rather low, so that the equilibrium angle when you first turn it on is fairly low angle here. And then you are slowly rising this up with an integral term through a large angle. And then you reset it to 0 when it gets to the criterion. It, of course, is going to drop back down. And the solution for that is don't reset to 0. Reset to 0.95 of the initial value.
You're saying 2.9?
To 0.9, 0.95, 0.999, whatever you love.
Right, but it's still, sometimes it doesn't do that, sometimes
Are you saying it's not deterministic? Have you chatted with it? I'm joking. I'm joking. The beam has free will. But no, you say sometimes, okay, so now you're saying, is there some nonlinear effect that you're not accounting for? It is possible that down here at the bottom you have kind of a pigtail of wire coming around which acts as a spring. And if that gets displaced from time to time, then the behavior will be different between different runs. I think that the friction in the bearings of the potentiometer are rather reliably good. So I don't think it's stick-slip in the potentiometer. I think, though, that you may have an effect of this odd spring due to the wire around there. But I'd have to see that to tell you for sure. Now, there's also the possibility of noise, particularly if you're forming the derivative term as error n minus error n minus 1, because the error from over one time step is going to be on the order of, if the system is changing quickly, it's going to be on the order of 1 ADC unit. In other words, there's 100% quantization noise. And the effect of that is going to be to make the system quiver around some, to hunt. And the solution is don't form this error, rather form something like error times error n minus 4. In other words, look back 4 samples and take the derivative. In some sense, that's taking the average over 4 points. You could also take an explicit average. You could add together all the errors over a short time period and use that as an estimate, add together the differences and use that as an estimate of the first derivative. Does that?
Should we divide it by 4 sources?
Well, sure, but that just means use a smaller KP. I mean KD. Use a smaller KD. It's the same as dividing this by 4. Yeah, I mean, since you got control of everything numerically, you just compensate by changing the multiplication slightly.
Just to be clear with K key stuff, if you only have K key and you haven't reached the desired angle, then she turns more, she turns zero.
If you have only KP and you lift the thing up to the desired angle, the motor should stop. That is correct. The equilibrium position for any finite KP is going to be below the desired angle. That is why you have to have a KI term. Was that a hand I saw over there? Okay, I was out of the corner of my eye. Now, I haven't seen free will in a microcontroller. I have in Windows, but not on the microcontroller. The machines in the lab were all cloned off the same image. Exactly cloned. They're different. How did they become different? I don't know. I'm guessing bad memory bits, but I don't know.
Would it be worthwhile to try to tune our proportional or integral and our derivative being using like MATLAB, using like the system on that, or is that
So should you use MATLAB to tune the system? Hopefully, the simulator I wrote is at least approximately correct, and the numbers I got of that for the control parameters seem to be about what I entered into the C. Not exactly, but pretty close. So you could do that. There are some nonlinear, there's some effects that are hard to model, like this spring constant of the wire around that potentiometer. But so sure. What else?
Right, so I don't know if this question is like too technical, but like when you model this pendulum, like this is a naturally unstable system. So how did you make it so that you could like linearize it about each of those points?
So I didn't linearize it around all the points, but because I set the angle, the desired angle to 0 angle, could make the sine x equals x approximation for small angles, and the approximation that cosine theta equals 1 approximation, and that's good within a few percent up to plus minus 30 degrees. Outside of that, all bets are off. I didn't try and make it stable for that, although by messing around, I got it stable up to 45 degrees. But after that, it's really hard because the differential sensitivity increases up here. It's just more, it's harder to control. Down here, it's unconditionally stable.
But then couldn't you like control the torque of the motor so that like that's a new equilibrium position?
Well, the reason that this is stable down here is that the lever arm is increasing. Gravity, the torque due to gravity is increasing as you go up. And so you'd have to figure out how to reorient gravity, right?
I mean, isn't that done by the torque of the motor? You're making it so that there's a new position such that like it won't move.
Yes, but when you're up here, the G is in this direction. The torque required to hold this in position becomes 0 differentially. And so the system becomes arbitrarily sensitive to small changes.
Oh, but yeah, but that's an unstable equilibrium point.
That's right.
I got a question going back to the PID. For the integration term, we multiply by the total error and then we put the ceiling on it, right? How do we determine this value of the ceiling?
How do you determine the value of the ceiling, ceiling for the integral term? Well, I would argue that it makes no sense to set it above the maximum PWM on time, certainly. So 40,000 would be an absolute upper limit, because it's on all the time then. And so as a guess, I would say half that. But I'm just guessing, right? I fiddled with it until it converged. But you can see from the conversion time here, from the convergence time, that you see there's a transient here which was most of the motor, fast transient, and then this slow turn up here is the integral term. And that's 2 seconds. Could I have done better? Yeah, probably. And so I would have taken it from 1/16 to 1/8 and tried that. How good can you tune this? I'm not sure. At some point you get tired and say it's good enough. Actually, since then I've tried 1/8 and it was a little bit better than that. It didn't seem to affect stability much. By the time I got to 1/2 though, there was a permanent oscillation out here. Small amplitude oscillation, because the integral term represents a phase shift, a negative phase shift at high frequency, and therefore destabilizes at high frequency.
Isn't it a negative phase shift for all frequencies?
It is a negative, yes, it is a negative phase shift for all frequencies, but at low frequencies it doesn't matter because the total phase shift from the rest of the system is 0.
Oh, yeah.
So it's only where it starts to approach 180 that it matters.
How do you set up for DAC if we're having like 2 separate transactions and not being able to see them on the system?
So the DAC B is set up exactly as symmetrically with DAC A. Let me see if I have an example of that here someplace. Where did I put that? That would have been SPI. So you're going to clear a bit. You're going to wait for it to be empty. You're going to wait for it to be done. You're going to write. You're going to wait for it to be done. You set the bit. Then for the second channel, you clear the bit again. You do the second write. You set the bit.
I think that's what we're doing, but we're not seeing anything on our oscilloscope, but we're getting the correct print on our TFT.
I'll have to see it. I'll have to see it. 'Cause I saw your code briefly and it looked correct to me. In fact, you know it's working because it's running together now. I'm not sure we set both of the channels to read out the angle and it worked, right?
No, we put the
On one.
on one, and then we put the motor control on that one as well. And it showed up on A, but B would just not.
Okay, then I'll have to look. I don't. Yes, go ahead.
Did you do the SPI wait while busy?
You certainly have to do that. You have to wait for it to be. You have to wait for the channel to be empty before you can jam it again. Yeah. What else? So starting next Monday at 0800, I will order up to $20 of parts for every group. This is $20 cumulative over the length of the final project. And to order a part, you need to email me plain text, no formatting, no spreadsheets, the part number, and the vendor, and the quantity. Part number, vendor, and quantity. There's the first couple of weeks I'll be getting on the order of 100 or 200 part requests, and so I don't check anything. If there's a typo such that that renders the name of the part number invalid, it just doesn't get ordered. If there is a typo that results in the wrong part getting ordered, the wrong part gets ordered. Parts that are back ordered don't get ordered because you don't have time to wait for a back order. You only have 5 weeks. So you should check the parts you send me through the search engine of the vendor to make sure that the part number is what you expect. I'll order from 4 places: digikey.com, All Electronics, Adafruit, and SparkFun. If you want something that's not from one of those 4 places, you're going to place the order yourself. I suggest not ordering parts yourself from eBay. They're often very cheap, and you get what you pay for. DigiKey has a huge inventory and a fantastic search engine, so it's a really nice place to go looking for parts. Be sure when you look for parts that you check the pinouts to make sure you can actually solder these things, and if you don't know, come ask. All Electronics is surplus, often cheaper if they have what you want. Some of it's used, some of it's new surplus. Adafruit and SparkFun are aimed at hobbyists. They have a large variety of pre-built breakout boards for various parts that you couldn't otherwise solder. You certainly pay a good amount of money at Adafruit, but their boards are very nice and they're beautifully documented. Code examples, typically for Arduino. It's not the end of the world. You can adapt it. So put in your orders, if any. I'll order every week up until the last week of final project. So at least 4 weeks, probably 5 weeks. And the last week of school, which is the week of demos, is November 27th through Friday the 1st of December. Okay. November 27th through the 1st of December. The official due date for the project is your lab section that week. If you want a demo in lab, that's fine. I'll be in all the lab sections. You're going to demo to me, not to a TA, but to me. TA may be there also, but I want to see them all. To be early, as defined in the table of bonus points for being early, is relative to that lab period. However, there is going to be an optional extension, optional no penalty extension to the 4th through the 6th. All you have to do to claim the optional extension is to sign up for a demo slot during that time. Demo slot will open on the 1st of December for sign up at noon 00 on the 1st of December. You claim a demo slot, and then your project is optionally extended to that date. The written reports are due for everybody on December 6th. That is the day specified by the university for this class. Therefore, if you decide to demo on the 6th in the afternoon and your project is due at 10 p.m. on the 6th, you better do some writing before the demo, because half the grade is the write-up. So is the timing clear on this? I'll put this on Piazza also. But I want to warm you up for this a little bit. So, we have a little bit of time now, have a week or so to talk about topics that might be relevant to final projects. What would you like to hear about which is relevant to your final project? Power management? DSP? Generating a television signal? Huh?
How does stepper motors work?
How does stepper's motor? Oh, so something on stepper motor design, right? Pulse sequencing. So stepper motors. Yeah, okay. For Bluetooth or what?
Or UART, it's connecting someone to like a computer.
Ah, oh, that's a good point. Yeah, all right. So, in past years, part of Lab 4 has been to connect to the computer with the UART. I didn't do that this year. Let's talk about UART, steppers. What was the other thing? Or was that the only two? So, yeah, it's possible to open up a console window on your laptop that can talk to C, and that's useful sometimes when you want to not have a TFT or you want to be able to unplug something and have a zero cost option to unplug. Yeah.
Do you know if with the UART console, I don't know if this is a stupid question or not, if you can like run a local web server?
So that is an interesting question, because to run a web server, you have to have at least minimal TCP/IP. Because web services depend upon having a TCP/IP stack.
I don't know what that is. What repeat? TCP?
TCP/IP. And the reason I was smiling was a TCP/IP stack from Microsoft that runs on this architecture takes 3/4 of flash. In other words, uses almost all of the space in the program memory for the code. I would say that if you want to use TCP/IP, the best thing to do would be to get a TCP/IP module, maybe a Wi-Fi module, that lives outside the CPU, and to which you can send a UART stream. Then you can write web content on the PIC32, which is blasted out to the TCP/IP stack and appears as a web page.
So what I'm trying to do is I'm using a JavaScript library that pulls from a JSON, but the JSON I want to somehow connect the data that's sent from the PIC like to a JSON.
What's a JSON?
JSON, it's just like a file. Imagine it's a text file.
Okay, so if you can open a serial port in Python, then you can blast data across the serial port from the PIC at least 38 kilobaud, probably faster, probably 100. I can't remember how fast I've run it. At least 38 kilobaud.
And so I can go to this Python server, and then you can create a file, like just do some script in Python, create that file continuously, and then from there my HTML file can pull it.
So you don't have to use HTML to get data over to a PC. You can just...
Well, I'm displaying it on a web page, so I have to use HTML.
Yeah, so you'd put it into, yeah. You either build it on the PC or build it on the PIC32. I'm sorry, say what? RF communication. That's fairly general. Do you have something specific you're interested in? So for instance, are you talking about analog radio or digital radio, protocol?
I don't know anything about it. So.
Okay, so let me think about that one and decide what the right level is.
So just going back to the UART, I'm pretty unfamiliar with that. So if we say if we want to send data from the PIC to the computer, but we don't necessarily want it as like website content, we just want it as a text file, do we still need the TCP/IP? Or
No. That's if you want to build a web page. If you just want to send data, there is a hardware USART, Universal Synchronous Asynchronous Receive Transmit module on the PIC32, which will send out a serial stream of data to the PC and receive back full duplex a receive stream at the same rate. And this is a very old protocol. How old? The UART protocol dates back to at least the end of World War I, where the maximum transmit speed was 110 baud, 120 bits per second, corresponding to 11 characters a second, which is as fast as you could make a mechanical typewriter go. Because the output was a typewriter, was an impact printer. The current rate, the fastest I've seen anybody run this system is around 115 kilobaud or so. And the system is nice because it's full duplex. You can transmit and receive at the same time. It is asynchronous. There's no clock line. The system can be completely interrupt driven, so that there's no waiting around waiting for events to happen. It's really quite nice. I don't tend to talk about it as much now because it is an old protocol and because PCs in general don't have native RS-232 anymore. So at the other end over here, this is referred to as RS-232. There used to be a plug, a physical plug on the back of the PC into which we could plug an RS-232 port, and now there is not. And so we have to use a UART to USB adapter which simulates an RS-232 port as a COM port, and those little devices are fairly expensive and get lost easily, so my attrition rate is about half per year. And I just can't afford it.
Are these continuous streams of data?
Can be. You can, so each 8 bits of data takes 10 bit times because there's a start bit and a stop bit because it's asynchronous. So you can run this at full transmit rate more or less indefinitely until you fill memory or break something because you've got too much data.
So the data that's being, so the data has to already be made on the PIC. It can't just like send it and then like delete where you're just sending.
Sure, you can do that. Let's say you're sending ADC data.
Mm-hmm.
You could easily support 1,000 samples a second through the ADC. Stream it directly to the PC where MATLAB plots it as a EKG or whatever. Right. So I can talk about that. UART stepper motor, RF methods. I2C, oh, the pain. I'll talk about I2C. I2C is popular. What's it stand for? Inter-chip interconnect, I think, isn't it? Isn't that what it is? I think it's I think Philips protocol that's been stolen by everybody. It's a 2-wire protocol.
Integrated circuit.
Integrated circuit communication. So it's meant for single board, short distance. The interesting thing about it is the data line is bidirectional and the clock line is typically handled by one central sort of star device that radiates out to others. So you'd have the controller here, the master so to speak, and then there's a data drop and a clock drop to up to 128 peripherals, which are addressed using a 7-bit address and which requires a pull-up resistor on each of these lines. And the single biggest failure mode for student projects is forgetting to put on the pull-up resistors. Sounds silly, but it's not, right? It's just one more thing that you should be built in, but it's not. And the reason it's not built in is that the size of this pull-up resistor is related to the number of peripherals you hang on it. The more peripherals, the lower the pull-up resistor value. So you have to be able to choose it. And it's fairly slow. There's 2 speeds. There's 2 standard speeds, 400 kilobits a second and 1.4, 1.7 megabits a second.
Do each of these VDDs have to be connected to a digital pin? Or can they all like...
Say again, I'm sorry, what?
Do they all, so does each peripheral have to have its own digital...
Yeah, each peripheral has to support I2C.
No, but do they have to have their own digital pin to supply that?
No, this
For that, the VDD.
This VDD is common for the whole bus. It pulls up the whole bus because every one of these has a transmitter which is open drain. It's an open drain transmitter. And so the the units themselves, the master and the peripherals, can pull down a line, but they cannot raise it. So it's called a wired AND, or a, so it's a quirky protocol. It's hard to get set up sometimes. At least it's picky. So you say super annoying? I'll agree on that. I would say if you intend to use an I2C unit, assume one person weak making it work. One I2C unit is one person weak. The next I2C unit is another person weak. It does not scale. Because the command set for each different chip is different. That's not standardized. Only the low-level protocol is standardized. The command set for each different chip is completely arbitrary. You have a question? Yeah, okay.
Are you lowering the values of buffer resistor with more cables because you have like a higher capacitance on the line?
Yes, right, exactly. So this has to, there's some RC time constant here that has to be satisfied. So if you want to keep the speed up, you have to increase the drive power. It's exactly right. So you're going to end up using these because they're everywhere. But leave yourself enough time. Don't say, with 1 week to go, now we're going to add the I2C. Because it won't happen.
Question about what you mentioned before. The oscilloscope display of the motor signal stuff. Does it matter, like you don't have to have like 0 degree as like a representative of some kind of number from that signal. You can just have it scale so it shows the response.
Oh, so what you're asking is about scaling on the oscilloscope waveform. Is that what you're, yeah. So the DAC itself has a maps 0 through 4096, 4095 to 0 to 2.048 volts. So to get the most resolution, you'd probably want to scale your signals to be 0 to 4095. So the ADC output from the potentiometer, you might right shift 2 bits, and that would be just about right for the DAC. The control parameter for the PWM, so the PWM output, you might want to right shift how much? Three, 4. You want them to be almost full scale on the DAC for best signal to noise without overflowing. And that'll make them both about 2 volts tall on the oscilloscope, which is a handy number. But yes, it's all relative. Anything else? Okay, I'll try and whip up some chat about UART, stepper motors, RF, and I2C. Yes.
Do you think you can put TV signals on that list?
TV signals?
Like VGA?
TV or VGA?
Any output to a monitor?
Okay. TV is interesting because it is a serial protocol, which means you can use SPI to drive it. VGA is more complicated, but more interesting. I'll talk about VGA, see what I can find on that. Yes?
Can you also talk about Bluetooth?
Aye. Well, Bluetooth, it's just a protocol, right? I mean, nobody in their right mind is going to rewrite the Bluetooth protocol because that's, I don't know, a person century of work or so. So you're going to buy a chip that has Bluetooth protocol built in and takes a UART stream. And the whole thing is then writing the registers on the chip using the UART or I2C or whatever you decide to use for a communication protocol. And I can't talk about that because I've never used one. I can talk about somebody's project who has used one, but you know, you can just read it yourself and cut out the middleman. I'll be happy to if you want me to.
Oh, can you talk about like the project you did, like when the dog is moving around and it triggers your phone, like that project?
Say again?
Every time like you got an alert on your phone, you said, "Oh, it's your dog." Can you talk about that project you did? I just
That's just a motion detector I bought.
Oh.
No, that's nothing I built. I've been thinking about a really good project would be to automate the door on the chicken shed.
Oh.